Welcome back to Introduction to Symbolic Logic. This is Lecture 7. Today we are going to start out by finishing our discussion of basic inference rules. So we need to introduce 3 more pairs of basic inference rules, which are disjunction introduction and elimination, bottom introduction and elimination, and negation introduction and elimination. And then we are going to talk about a couple of proof strategies, meaning tools, ideas, strategies that may help you to develop complex proofs. Specifically, we are going to talk about backward planning, forward planning, and indirect proof, which are the 3 most important proof strategies. And then in the last part, we are going to talk about derived inference rules, which are rules that can be justified by means of our basic inference rules. So let's talk about disjunction introduction and elimination. Disjunction introduction is a very simple inference rule. The basic idea is that if you have shown that A, you can infer any disjunction with A as disjunct. So in particular, you can infer A or B. So for example, if you know that Anna is at the party, you can infer that Anna or Bill is at the party. You can also infer that Anna is at the party or elephants are green. You can infer that Anna is at the party or whales live on the land, and so on and so forth. You can infer any disjunction where one of the disjuncts is that Anna is at the party. So formally, this rule looks like this. Suppose that in line M of your proof, you have a sentence of the form A. You are then licensed to infer the disjunction A or B and justify this inference by citing disjunction introduction as applied to line M of your proof. So here are a few examples of correct applications of disjunction introduction. To start, in the top left corner, suppose that in line M of your proof, you have the sentence A. You can then infer a disjunction A or B, where A is one of the 2 disjuncts, and justify this inference by citing disjunction introduction and line M. To give you a second example, suppose that in line M you have a conditional, if A then B. You can then infer a disjunction, if A then B or C, and justify this inference by citing disjunction introduction and line M. It here does not matter whether you add the new disjunct to the right-hand side or to the left-hand side. So for example, suppose that in line M of your proof, you have the conditional if A then B. You can then also infer the disjunction C or if A then B and justify this inference by means of disjunction introduction applied to line M. To give you a final and somewhat more complicated example, suppose that in line M of your proof you have a conjunction, A or B and C. You can then infer a disjunction of which this conjunction is one of the 2 disjuncts. Say you can infer A or B and C, or B if and only if C, and justify this inference by disjunction introduction applied to line M. Disjunction elimination is somewhat more complicated. The basic idea is this. Suppose you have established a disjunction, say A or B, and suppose furthermore that under the assumption that A, it follows that C, and under the assumption that B, it also follows that C. You can then infer C. So the idea is that if either A or B, and in either case C follows, you can infer that C must be true. So for example, suppose you know that either the butler or the gardener did it. And you can infer that if the butler did it, the culprit is a house employee. And you can also infer that if the gardener did it, the culprit is a house employee. So since in either case the culprit is a house employee, you can infer that in fact the culprit is a house employee. So what does disjunction elimination look like formally? Formally speaking, disjunction elimination makes use of two subproofs. Suppose that in line M of your proof, you have the disjunction A or B. And suppose also that under the supposition that A, it follows that C, and under the supposition that B, it also follows that C. You can then infer C and justify this conclusion by means of disjunction elimination applied to line M, that's the line with your disjunction, and the two subproofs, N to O and N prime to O prime. So here are two examples that illustrate the use of this rule. On the left-hand side, we see an example that is very similar to our general statement of the rule. Suppose in line M, you have established A or B, and under the supposition that A, it follows that C, and under the supposition that B, it follows that C, you can then infer C. On the right-hand side, you see a more complicated example. Suppose that in line M of your proof, you have established the disjunction that either if A then C or B and D. And then suppose that under the assumption that if A then C, which is our first disjunct, it follows that F if and only if G. And under the supposition that B and D, which is our second disjunct, it also follows that F if and only if G. You can then infer that F if and only if G, and justify this inference by citing disjunction elimination, the line that contains the disjunction, and the two subproofs, in this case from N to O and from N prime to O prime. Here's an example of a Fitch-style proof illustrating the use of disjunction introduction and disjunction elimination. So we are proving a disjunction, A and B, or A and C, from the assumption that A and B or C. So our assumption is a conjunction, the main connective is a conjunction sign, and the conclusion is a disjunction, the main connective is a disjunction sign. And as always, I've drawn a Fitch bar underneath my premise and labeled the first line 1. So how can we prove this? Well, I'll just start by simplifying my assumption, or just taking out the two conjuncts simply because I can. The first conjunct is A, the second conjunct is B or C, and I can justify this citing conjunction elimination and line 1. And now I have a disjunction in line 3, and I'm going to set up this disjunction or use this disjunction in order to set up a proof by disjunction elimination. So my basic thought is that if under the assumption that B, it follows that A and B, or A and C, and if, likewise, under the assumption that C, it follows that A and B, or A and C, if I'm able to complete both of these subproofs, then I can infer my conclusion citing the rule disjunction elimination and lines 3 as well as the two subproofs. I'll just put two question marks here since I don't know the line numbers for those yet. So the main thought here is, look, I know that either B or C is true. If I can show that under the supposition that B, our desired conclusion follows, and if I can also show that under the assumption that C, the same conclusion follows, then that conclusion must in fact be true. two possible cases. The conclusion follows in either case, so we can draw the conclusion. That's the main thought here. Well, let's see whether we can actually prove this. So I'll put some question marks here just to remind myself that I have not proven this yet. This is what I want to do. This is not what I have already done. So how can we get there? Well, in line 4 we have B, and I also see that in line 2 I have A. So I can infer A and B and cite the inference rule conjunction introduction applied to lines 2 and 4. And now I see that I have established the first disjunct of this disjunction here. And so that means that I can infer the whole disjunction citing disjunction introduction and line 5. That completes my first subproof. I have shown that under the assumption that B, our desired conclusion follows. Now, can I do the same for the second subproof? Can I also complete the second subproof to establish the same conclusion? Well, let's see. So in line 7, we are supposing that C, and again in line 2 I still have A. So I can infer A and C, citing the rule conjunction introduction and lines 2 and 7. And that means that I have now established the second disjunct here, A and C. And the rule disjunction introduction then allows me to infer the disjunction, of which I have already established one disjunct, citing disjunction introduction and line 8. So that completes the second subproof. I've shown that under the assumption that C, our desired conclusion follows. And I can now fill in the gaps and supply the justification for our final inference. I can now infer that A and B or A and C, citing the rule disjunction elimination and lines 3, as well as the two subproofs from 4 to 6 and from 7 to 9. I just add that here, 4 to 6 and 7 to 9. And that completes our proof.